Hey, good evening, guys. Sorry I don't have an overlay there of the weather, but I've been having Sony Vegas crashing constantly, so we're just kind of doing things manually here. But there's a little bit of time lapse from earlier. And what does it look like outside now? Let's switch over the feed, and you can see an anvil spreading overhead from the east, of all things. You notice how we've got the towers right there in the center, and they're spreading from left to right. That is motion from east to west. So a little bit of a different pattern, and we'll take a look at the surface chart here. There we go, we got that up and running. Let me do one thing before I get any further. I've got to switch some windows around. Give me just a second here. And I think we're pretty much good here. All right, so yeah, looking across Texas, we've got that southeasterly flow coming back. Dew points up in the 70s, so we're getting in a very normal pattern for July. So we're pulling in flow from the Gulf there. We had an outflow boundary across central Texas in this region right here yesterday. Very cool temperatures in part of East Texas, but that has changed. We do have a 79-degree reading right there in Lufkin, but they've had some showers in that area. But it looks like maybe that outflow boundary has shifted maybe north. They don't just disappear overnight. So we use our tools like radar and satellite to try to pin down where the changes are. So let me go over to the charts here. See a little bit of a kind of a troughing appearance here in the pressure lines, so there could be a little remnant of that boundary right through the Dallas area. We are seeing some showers out there in the Longview area, but not much going on here. Things are a little bit busier out in the southeast U.S. Let me bring up that sector right there. And there you can see showers all the way from the Tampa area up to southern Georgia. But everything under the influence of the Bermuda High. So there you can see the synoptic scale ridging extending from east to west. And that's the Bermuda High starting to nose in and dominate the weather in this area. And then up north, things are a little different. We've got a frontal system up in that region. Looks like maybe a supercell in the, looks like possibly around Grand Forks, right there. A couple of other strong cells up near the border. So what we've got here is a low pressure area very close to where that supercell is. Possibly a cold front moving south, maybe even all the way down here. And then very likely somewhere out ahead of the system we've got a warm front. So we'll pull up the surface observations and try to get an idea where that is. We see lots of 80s in the Omaha area. Very high dew points, 77, 79. Well, this is off the bottom of the map. Hang on a second. There we go. So yeah, you can see that 79 dew point. The irrigated cornfields really add a lot of moisture to the boundary layer. So we don't really see the cool conditions until we get up into Minnesota. And now around Duluth, 64, 72 at Brainerd, 70. Yeah, lots of 70s across northern Minnesota. So based on this, I would put that warm front probably something along a line like that right there. And then the cold front would extend into Nebraska. And then north of that, of course, we would have a occluded front. So you can see the slight backing of the surface flow north of the warm front. So that helps to circularize the bottom part of the hodograph. And that helps increase the streamwise vorticity and gives us an environment very conducive for supercell development. We'll bring up that radar, and it looks like we do have a couple tornado warnings in that area. We'll zoom in on that cell right there. Looks like a very potent storm there. Looks like a classic supercell PDS warning for damaging tornado. Radar indicated rotation, so I don't know if they have any spotters out there in place. But you would have to kind of be in this area to really see what's going on out ahead of where the circulation is. But you can see definite hook here and kind of a ball structure. So that's suggesting the vortex is right in that area. We'll go to storm relative velocity, and we see some very strong motions. Remember, red and purples are going to be your outbounds. And the radar sight is up this way. So we have outbound right there and inbound. And it looks like the inbound is kind of weak here. So if we really want to find the vortex, we need to kind of balance out the inbound and outbound. And we do that in GR level 2 by setting a storm motion vector. So before I do that, let me take a look at the storm motion and just kind of get a baseline. Okay, we got it moving from the northwest. So we're going to do a vector of maybe 310 at 15. And there we go. That balances out the mesocyclone just a bit, and the diameter on that appears to be about 3 to 4 miles. And I don't really see a tornado signature here, and that's where you have very, very close proximity of the inbounds to the outbounds. What we have them is pretty well separated, but definitely rotation. And let's see here, we've got a little bit of diagonal axis between those two dipoles there. So that would indicate a little bit of convergence with that circulation. Looks like the strongest circulation is right about there, and that puts it pretty close to where that RFD is punching through. Then we go to storm relative, or the spectrum width, and this definitely appears to be the rear flank downdraft. This is kind of a good product for finding your boundaries. Now, I wish there was some way I could trace that and put that on the reflectivity, but I'll just put a dot here and try to transpose that the best I can. But that's going to be your rear flank downdraft punching out eastward, and some very good hail. If you're right here, you're going to get hit by probably some good 40 to 50 mile an hour winds, and then a lot of wind-driven hail. Okay, before I get any further, let me take a look at the chat. Hopefully your levels are looking good here. Sue M. and Justin, Dave, Mike Estwick, Megan John. He says, hello from Minnesota, enhanced risk tonight. Crazy hook there. Saw velocity readings of 107. Hiker Arizona is here. Burl H. Talking about that tornado spotted by a state trooper from a plane in eastern Iowa. Okay, I didn't notice that. I guess there's a storm out ahead of the line. Is there? Let me check. Yeah, a couple cells out there in eastern Iowa. And that does look like it's pretty much along that warm front that I kind of traced out right there. So you can see the contrast there, 90 degrees in the Des Moines area, and then these readings here closer to 80, and you can see the backflow right there. So that's the reason why warm fronts are very helpful for tornado formation. Let me see if I can find a photograph. Without going into Rayob, how do we get a photograph? I guess we're going to have to... Let me see what we get from the University of Wyoming. I know we get mini photographs at UCAR, but let's see here. Yeah, photograph. Of course, this is going to be data from this morning. But let's take a look and see what comes up. Okay, let me pull up a slightly different one. Yeah, I guess we'll go ahead and use the Minnesota one. I was hoping to get more of a cross appearance to that photograph so I could show you a couple of principles here. But this is showing northwesterly flow. So you can think of the 00 as the ground. And they were good enough to label the height of the photograph in millibars. And this is where it's good to memorize the millibar values as far as height. For example, 850, that's going to be 5,000 feet, MSL. 700 is going to be 10,000. 500 is going to be about 18,000. And then 300, that's at about 30,000 feet. So we're concerned with the lowest values down here in the lower part of the photograph. It would be good to have a pressure reading at the ground. As far as station pressure, we would need that there to see how deep the layer is. But just taking a guess here, you can see there's a little bit of curvature to the photograph right there. And we get that by having winds at the surface, for example, out of the south, adding a little bit of directional change like that, and then by the time we get up to 810 millibars, the flow is out of the west instead of the south. So that's the turning of the photograph caused by directional shear, and also speed shear can be important, but you can still have kind of a uniform wind as long as you have the turning. You can get a curved photograph that way also. Now, as far as storm motion, this is kind of where we work out things like the bunkers method. For storm motion, we can use the lower 6 to 8 kilometers or so, and just kind of find a mean point capped off by, let's see, we're at 6 kilometers. That would be about, I'm going to cap it off like maybe right here, 360 millibars. So I'm considering all of the photograph, all of this, and I'm trying to find a mean point along that line. So I'm going to come up with probably a value right in here, and that's going to be, actually maybe it's going to be more over here, and that's the storm motion. So you measure that relative to the ground, and you can see we get a motion from west-northwest to east-southeast at about maybe 8 knots right there. And then using that dot, we can work out the bunkers method at rightward motion for right-moving severe storms, and that gives us more of a south-southeast movement there. So anyway, we could talk about that for a whole hour, but that's kind of the basics what we look at on a day like this, and that's the reason why warm fronts are very important, because they can take the surface wind and really stretch that bottom part way over here. So instead of south flow, you have southeast flow, and you get a longer trace like that. So not only do you lengthen the shear, but you have an increased storm relative helicity due to the increased curvature. And we measure that curvature relative to the severe storm motion plot like that. And we see how much area is swept out in that region right there. So the longer you can get that line relative to this motion vector, that'll give you a lot of storm relative helicity. So that's kind of the way it works there. So what we got to keep in mind is warm fronts and backed winds, especially a localized backing where you don't have as much of a response in the mid-levels, that will really get storms going, severe weather. All right, there's the enhanced risk up in the northern Dakota area. Let's take a look at the hemispheric pattern. This is up at about 300. No, this is 500 millibars. Okay, so let's go back and go back maybe 5 days. You can see we had a ridge over British Columbia, ridge over Alaska, very hot temperatures. And then over the past 5 days up to now, you can see we've broken down the ridge and kind of forced it northward. And then we close off this low here off the coast of British Columbia. So when we close off the circulation and we've got the jet north of there, that's kind of a blocking pattern. So we're going to look for the patterns to be kind of locked up here, at least for several days. So we're probably going to have a continuation of this zonal flow in the north U.S. and northwesterly flow in the Hudson Bay region. So there's the pattern right now at 200 millibars. Just showing zonal flow across the northern plains, and where we have the stronger flow, that's where we're supporting enhancement of the storms there. Where we have weaker flow, you're going to have weaker storms. So there's 50 knots right there, and we'll zoom in on that real quick. 50 knots in Minneapolis and 65 back over Bismarck, and this is the area this morning that moves out where the storms are. So basically we're seeing about 60 to 65 knots over those storms. And already some changes there in the past few minutes, and still got the tornado watch or tornado warning up. Shear is looking a little bit tighter here. For example, right here, shear is coming together pretty well, and looks like another area developing out ahead of the storm. Well, actually within the storm, but just out on the forward flank right there. And that could be a new meso coming together here. This is kind of like the rain-free base right there, and that's where spotters are going to be watching. That's going to be just west of the town of Ada, Minnesota. And then, of course, we have a couple of other storms. This one's a little bit weaker, had a tornado warning earlier. This is near Red Lake Falls. And the velocity looks a little bit weaker. You can see some inbounds there and outbounds there. I don't know if there's anything down there. Let me see. Yeah, a little bit of, I guess, maybe weak circulation right down there. But the big storm there crossing into Minnesota. Okay, 250 or 200 millibars there, showing the zonal flow across the northern states. And we'll go down to 700 millibars. And we see the return of some cool temperatures at 200 millibars. We didn't have quite as many storms as today, so even though we have cool mid-level temperatures, it appears something is precluding storm formation because we've only seen storms in the Longview area. So we'll have to check out those SQTs there. The stronger capping, though, that's going to be confined to the central plains where we have this 15, 14 degree reading, 13. Again, this is at 700 millibars, about 10,000 feet. And some of the capping extending up into South Dakota and Iowa right there. And there's the storms, and we're going to take a look at the soundings next. And the big one is way up here, and then we've got other cells down through eastern South Dakota. Okay. You can see the problem I have with Firefox here. I've got like 31 products open on these tabs here. And if I click too hard, it spins like really fast. It kind of scrolls. And then I kind of lose my place, and it's not really a good way to... I wish I could kind of click this and just do one... kind of like move this very gradually a bit at a time. Okay, so, yeah, let me see here. I'm trying to find the soundings. And there we go. Okay, I'm going to set this to SQT, and we'll take a look at Fort Worth first and try to find out why we don't have a lot of thunderstorm activity. Now you can see it appears that there's some dry air aloft. Okay, so that's a big change from the past few days. Okay, so there's the possibility... I mean, well, the dry air is very high aloft, but when you start involving dry air like this, that means when you have the churning of air, mixing of the boundary layer, you have some descent and ascent, and you're basically churning up the boundary layer. That can transport some of the dry air down to the surface and mess up the rising parcels. And it does appear there is some dry air also around 900, 800 millibars. So that might have been what did it. So we've got dew points around 70 at the surface, but just off the surface, dew points are more like 60s. So if we try to take 90 degrees and lift that, and we mix this layer here, it looks like we're still looking at some capping. And we've got warm air loft up there. 550 millibars warm air. So that's going to take away from some of the cape. And we can visualize that warm air by looking at the 500 millibar chart. Okay, so we see -6 there at Fort Worth. And let me look at the SCUT one more time. And let's see here. 500 millibars is located right here. That's showing, yeah, that's showing -6. Okay, so really we need to see temperatures more like -8 to -10 there at Fort Worth. I think I may have made a mistake when I was reading this. Okay, yeah, that's what confused me. Sorry guys. Yeah, see, I was trying to remember the temperatures we had from a few nights ago or a few days ago, and I'm kind of confused whether we were seeing 8 at 700 millibars or -8 at 500 millibars, so I'm starting to get a bit confused here, but I can see by the sounding we need 500 millibar temperatures to be a bit cooler than this to get storms going. Let's see, 8 at 700 millibars. Okay, yeah, I think when I was talking about this 3 days ago, I was talking about the 700 millibar level. So, yeah, we do have the steep lapse rates. That's what I was trying to remember. Definitely steep lapse rates, but still just enough dry air to keep the storms from going. And even if they did get going, they would have to kind of overcome this, and that's going to cut down on the Cape quite a bit. All right, satellite data. This is the polar orbiter. And you can see some early morning storms across the Lake Charles area. Let me put up the state lines. And you can see Lake Sabine right there. This is East Texas right here. And there's the towers going up in that region. And we'll see what it looked like later during the afternoon. Yeah, I think this is the late afternoon shot right there. This is probably about 1 o'clock. And I think this is earlier. So there you can see this is probably more like 11 a.m. So not much going on in East Texas early on. And then later during the day, yeah, these went up. And then you saw the opening sequence, some of those storms moving eastward to the area just southeast of Dallas. And also a few towers, so yeah, the soundings did not completely shut out convection. It's just there was just enough capping to keep things shut down. And that reminds me, I wanted to talk a little bit about College of DuPage's site, because that's a good place to get data. Let me try to bring up a window here. You have to do these tricks with Firefox. If I just go in here and open a tab, it's going to put it way at the very end of the queue. So I'm going to open one of these links, and you can see it puts a tab right next to here. So I can just put in weather.cod.edu. And I think this is one of the better university sites. They've got a lot of well-written tools. And you can see they've got a storm chasing program too. And what you can do is go to the satellite and radar here. And then on the left tabs right there, you can pick different scales. In this case, we can take a look at North Dakota. Actually, I want to take a quick look at Texas before I do this. So I'm going to use the 2 kilometer, and I'm going to look at the satellite imagery. So I clicked on Texas, and they give you the satellite image here, and you can, this is what I really like, they've got the scroll bar at the bottom, so you can animate it the way you like it, and go back to maybe 3 or 4 hours. So if I move that bar, you can see the storms there in East Texas working their way westward. And you can also put on different fields. And what I wanted to look at here was the convective inhibition and see how that did, because there was a little bit of convective inhibition across North Texas. And I'm kind of curious what it showed. And it seems to show an absence of convective inhibition. I would have expected to see more of that shading covering North Texas. But that's a very delicate thing for the models to handle, so it's probably not much of a surprise there. And then we'll look at CAPE. We can put on CAPE there at the bottom. And there comes the CAPE, and you can see values 3,000. That's pretty high. I don't know what kind of CAPE this is. That's very important. You have to know whether you're looking at most unstable, mixed layer, or surface-based CAPE. And I think what we may be looking at, these values are very high, and I suspect that this is most unstable CAPE. And then a very valuable field is theta E. And we look for the highest theta E values for initiation. And you can see a bit of a theta E ridge right there in southeast Texas. And that's kind of joined up with higher theta E also in Oklahoma. And then by moving the slider, you can see the values kind of change from hour to hour. Okay, then I'll show you the purpose of some of these other fields. We went through CAPE, sea level pressure, that's pretty obvious. That shows you your southerly flow off the Gulf. Theta E, that's just pretty much a combination of temperature and dew point. The higher your theta E, the more your parcel will be to the right of this QT diagram. So given equal upper level conditions, parcels with a higher theta E will favor convection by far. Vorticity, that's a good way to find what you're looking for here is kind of shear in the lower atmosphere. This is horizontal, or I'm sorry, this is shear across a broad area. So like if Abilene had northerly flow, Dallas had southerly flow, that would indicate rotation in this area. So that's vorticity, and it would show kind of like a max in this area right there. So that's what vorticity is. And it's showing positive vorticity right there, so probably some sort of thermal low there in Mexico. Okay, convective inhibition, that's kind of obvious. That's the amount of capping you have. That's preventing a parcel from initiating. Pressure falls. Now, you can see one of the problems we have using internet products. Pressure falls, we don't know whether this is 1 hour or 3 hour or 6 hour. So I can't tell you what this is. That looks like it's in millibars. I don't even see the units here. Okay. Theta, this is going to be strictly your temperature reduced to 1,000 millibars. So this is kind of like temperature adjusted for elevation. It's a good way to find fronts in the mountains. So you can definitely use this out in the Rockies. And then watches and warnings, that's pretty self-explanatory. A couple of, looks like flood warnings up in Arkansas. Dew point, that's the amount of water vapor near the surface. So 74 degrees right there, a lot of moisture. Station plots, you can use that to find your fronts and low pressure area, stuff like that. Wind vectors, that's just your winds mapped out as a grid. wind gusts that shows you your wind gusts reported in the past hour. So you can see that change right there. Stronger gusts, looks like in Oklahoma. Then streamlines, that's just lines paralleling the wind flow in the at the surface. You do have to be careful because this is kind of a smooth field. So this is more representative of the synoptic scale flow. I would not use this to try to find mesolows, for example. I would be very hesitant to do that. I would look at surface plots for that, because sometimes all it takes is maybe 1 or 2 plots. And also, this is probably coming from the rapid refresh model, which is a couple of hours old, and your station plots are always up to date. So you're going to be looking at this to find mesolows when they do form. Composite radar, that's your highest reflectivity from the surface on up to the top of the volume. Moisture divergence is a combination of convergence of the wind, so where the wind flow is coming together like this, and where you have high dew points. It's kind of multiplied by the dew point there. So this is could be one way of finding where initiation is, but you can see it did not work too well for today. We're showing moisture convergence. Minus indicates negative divergence, so that's basically moisture convergence. And then your blue is moisture divergence, where it's spreading apart. But maybe some of the higher values here maybe did help with this little cluster over San Antonio. Temperature, self-explanatory, the amount of temperature, molecular activity. Supercell composite, that's looking at your shear, your relative humidity, your helicity, stuff like that, all combined together. And I prefer looking at pivotal weather for stuff like that. Okay, so that's a rundown of a lot of the products there on the College of DuPage site, and they've also got the individual NEXRAD stations, and we can take a look at Grand Forks. And there's our cell right there, and they've got a lot of different products here. And it does include some of the dual pole stuff like differential reflectivity, correlation coefficient, and KDP right there. Okay, so we'll go ahead and move on, and let's see where we're at. I think we're probably ready to do the forecast here. And I wanted to do the forecast looking at the upper level data for the hemisphere for at least North America. And you can see that low right there. Let's see what happens to that. Yep, just kind of shears on off and kind of spins around out in the Northeast Pacific. And you can see this cutoff high here in Alaska. So it looks pretty warm up there. And this is a classic blocking pattern. This is what we call a Rex block. It's similar to an omega block, except it's basically a cutoff high north of a cutoff low. So right there, that forms the Rex block, and that kind of keeps the patterns persistent downstream and sometimes upstream. So what we look for to kind of break that up is a trough approaching from the west. Otherwise they tend to persist. And yeah, here comes a trough from Russia. And that looks like it breaks down the ridge and merges into that trough there around the 20th. And there goes the trough out into Canada. But it looks like it leaves another trough off the Oregon coast right there. So once again, another attempt to block the patterns here. So you can see the flow there amplifying again across Alaska. We don't quite have a cutoff high yet. So it looks like that trough just kind of gets lifted by this next approaching trough later in the month. This is the 25th here. And there's the next system coming inland. So that's one way of reading the upper level patterns there, just looking for troughs and also the position of the jet. Now the other thing that's important for the United States itself is the ridging, the upper level ridging. So let me back this up. And what I want you to look at here is the 972 decameter line right there. So we're going to move this forward. And you can see it backs off a little bit, shrinks a little bit, and then it kind of moves inland. Recedes a little bit, probably diurnal there. Comes back a little bit. And now we see it covering a lot of the central U.S. here. A little bit of a low here in Texas. So we're seeing the heights come up across the southern United States, and that means the temperatures are going to be coming up too. So yeah, you can see now 972 covering a huge area. So that's going to be the return to summer here. It looks like that low there shifts to the Big Bend area by the 13th. That's in a couple days there. And now we see a 978 start to form there, so looks like some hot weather in the desert southwest. 972 kind of backs off here. Looks like a little bit of cold air pushing south through the Midwest just after the weekend. Then the ridge builds back in. There it goes into the central U.S. Building in, building in, building in. And then we see a 978 pop up across Missouri around the 20th. So that's probably going to be a bit of a heat wave maybe through the Midwest late next week. And around the south side of that, we're going to see easterly flow in Texas. So a bit of a tropical pattern setting up for the southern U.S. right there. So there's that upper level high persisting over Missouri. Looks like a little bit of troughing there along the Texas coast, so probably maybe some rain activity south of Dallas through the period. And then we see the upper level high just kind of move around in the central U.S. And at the end of the period, it's over Nebraska, so probably some very hot conditions there late in the month. And looks like that upper level high recedes to the Rockies at the end of the run. So you can see that kind of tells the story about what's happening there. And the other thing is, even if you get like, usually we go through the dew point charts and we try to find the fronts moving south and we see the moisture working up northward. You're not going to have thunderstorms along these boundaries if you're right underneath one of these upper level highs. That's going to tend to produce a lot of subsidence and capping. So it's kind of good to look at this chart in addition to the surface charts also. Okay, for the mesoscale, let's see what's going to happen overnight. We're looking at the central U.S. here. Looks like an MCS moving out of Colorado, very typical pattern. Shutting down overnight. Another one moving through Iowa. And I guess those storms up in Minnesota, they'll probably also form up into an MCS and move into Wisconsin and Lake Superior. And let me see what's going on in Texas. We'll check out the mesoscale there. We see a bit of a cluster there in southwest Mississippi. And looks pretty dry. Southerly flow, a little bit of a nocturnal convective event, I guess, again in the Beaumont area. And then some popcorn cells right there in East Texas, probably with the sea breeze starting to lift northward. I guess we can take a quick look at moisture depth. This is 850 millibar dew point on the NAM run. And looks like some pretty good moisture depth. The blue that you see here, this is dew points at 5,000 feet of 60 and greater. and that's pretty widespread. Looks like that dry air that we had across Tennessee and Arkansas, that is starting to recede a little bit, and the boundary layer is starting to deepen through the central U.S. And let's see, we see the moisture deepening a little bit in the Midwest. Not quite so deep in the Gulf Coast here. I think that may be diurnal right there. Yeah, that's what's going on. Nocturnal, things tend to shut down, a lot of dry air, and then when we get convection later in the day, the boundary layer deepens, and some of the moisture comes up to 5,000 feet there. And there's the next day. Lots of moisture there in the southern U.S., all the way out to I-35, and more importantly, the upslope flow. That's more significant when you're bringing moisture up to 5,000 feet in the high plains. That's going to mean thunderstorms all the way up into Colorado there over the next couple of days. Then we'll look at the surface chart and close things out, I guess. So there's our frontal system there in the Dakotas. This looks like a thermal low mostly over Kansas. We run the charts forward, and for tomorrow's WEATHERCAST Wednesday, looks like that front pushes southward into Kansas right there. Another little frontal system moving through Iowa and Wisconsin. Kind of looking like that right there. High pressure across Ontario and Manitoba, driving cool air into the Great Lakes region and down into Nebraska. Meanwhile, moisture coming up from the Gulf of Mexico, all the way up into Illinois, Indiana, and you can see the Bermuda High off the right side of the map right there. So moisture kind of working its way around through the Gulf of Mexico, then moving up into the central U.S. Much drier air, though, out in West Texas, so maybe a little bit of a dry line, perhaps. Weakly defined dry line in Texas and Oklahoma there. For Thursday, front from Chicago to St. Louis to Wichita, gradually sinking very slowly southward. Best chance of rain is where your stronger flow, stronger moisture reaches the frontal boundary, so it looks like a good chance of convection in Kansas and Missouri. Then Friday is looking like this. Front appears to be right through here. Looks like it's kind of contaminated a little bit by convection in this area right here. But I do see backflow in the Red River area. So probably somewhere in Oklahoma we find that front. Yeah, that's what it looks like. Then for Saturday, high pressure right here. High pressure over Missouri. So my question is whether that is synoptic scale or I'm sorry, like whether that's from an air mass from Canada, or whether that's from a meso high, additional convection kind of reinforcing that. Let me go backwards and see what's going on. There's our high right there. You can see the anticyclonic flow. So I'm backing it up. Yeah, that comes from Canada. Okay, so that's cold air coming southward into Missouri, and that's going to drive the cold front. There it is right there into the Red River area on Saturday. So there we see the high pressure area around Paducah. Very weakly defined cold front. Looks like it's pushed all the way to I-20, Shreveport, Dallas. So it looks a little bit possibly wet over the weekend with that front in the area. And going into Sunday, probably just kind of a stagnating frontal boundary right there. Monday shows cyclogenesis in the North Plains. It's like a reinforcement of high pressure in the Great Lakes area, driving probably another front southward into Mississippi River Valley. Tuesday, pretty much the same. And the browser is glitching just a little bit. Give me just a second here. Okay. Let's see, where were we at? Let's see. Sunday, Monday, Tuesday, Wednesday. Okay, so new frontal system coming together next week around the 19th and 20th in the northern plains. So it looks like more thunderstorms for Iowa and Minnesota. And there's the front right there, driven by this high pressure in the Great Lakes area. Then we see the southerly flow come up around the 22nd. New push of cold air into the Midwest. And that doesn't make much headway into Texas. So most of these systems are moving southeast through the Great Lakes area, and boundaries kind of stalling in this area. So it looks like kind of a rainy pattern there for the western Midwest, all the way up into the North Plains, and then down probably to Oklahoma. So that's definitely good news there for the agriculture. I don't know if that's interfering with any harvests, but of course any rain is, as long as it's not like 1993, any rain is certainly good there. Let me take a look at the chat, and then we'll see where we're going to go after this. We'll have to skim through this, but Ryan says South Florida under heavy rainfall. Ryan, seeing Ryan's name reminds me of the tropics, so let me check what's going on down there. Tropical cyclone activity not expected the next 48 hours. Okay, 5-day, nothing. So not even that wave there. And then the eastern North Pacific. We had that one, yesterday we had Hurricane Eugene up to 110 knots. Now it's down to 50 knots, weakening there. They're looking for another hurricane south of Acapulco. And then Eugene is going to work its way slowly northward. And I wonder if some of that moisture is going to make it into California eventually. I guess we'll have to see about that. Okay, let's see here. Let me give you something to look at. While I look at chat, I guess I'll give you the outside view. Alexi says, please hit that like button, and yeah, I do appreciate that. Mike says, storms south of Denver. I guess we can take a look at Denver radar. Okay, there's the storm in North Dakota, or coming out of North Dakota. Looks like, looks a little bit weaker there. Kind of precipitation wrapping up, and well, it's still got a strong mesocyclone there. Seeing 77 out and 61 in. That's 130 knots a shear. So yeah, it does appear this thing is still a beast at this time. Strongest velocity is right here and right here. That's the dipole, the two different signs of velocity. So the center is right there. I'm going to put a dot. Oh, it just updated. Okay, so let me revise that. Put the center of circulation right there. And you can see it's kind of in this little hook feature right there. So actually what we have here is more of an HP-ish storm. And then where we have very strong velocities coming together, that would be where we have a possible tornado threat if there's like consistency over time and through depth. Then that could be some sort of vortex. I don't see anything out in this area though. And the higher tilts, not showing any high velocities coming together. So I don't think there's much of anything on the ground right now, but this thing is probably spinning like a beast right now. Take a look at storm tops, see what the top of the storm looks like. In fact, I think I see a little bit of a donut shape. Yeah, you see that right there? That's probably the beware, the bounded weak echo region. And then above that, we usually find the higher intensities. And then the storm tops. Okay, so we're seeing tops of about 50,000 on this, and looks like new convection further down in this area right here. So it looks like definitely a lot of potential for this tail end storm. I think if I was on that HP, I would probably write that off. HPs are very difficult to chase and kind of dangerous. So if there was a way, I would probably move around and go to the backside. However, one thing that you see is the outflow here. So that may prevent that storm from really doing a whole lot. So you see that outflow boundary right there coming down. Yeah, the reason I was thinking that this was looking good is because of the very high intensities aloft. You see the 62 dBz's right there. Definitely a hailer, but I don't know if it can really pull that inflow together. Maybe it's just off the surface. Maybe it can get it going, but we will see about that. Let me take a quick look at Denver. While that's loading, isolated storms kept things reasonable in the Houston area today. Dave Donut says 14,000. Is it Donut or Donate? I don't know if that's French. 14,000 people evacuated from wildfires in British Columbia, and we did see a lot of widespread temperatures in the 90s there over the weekend. Eddie W. had a tornado warning storm there in Iowa. Wildfire from a lightning strike near NASA in Florida. Ryan says Canada is now under the fire lines more and more lately. Yeah, I still remember that big fire in Fort McMurray, I think it was. Near that, yeah, it was near that mining town up northwest of Edmonton. That was pretty bad, and I wonder what's been going on with that since then. Hiker got radar scope on his phone. It's awesome. Yeah, I agree, and I just got an email from Weather Decision Technologies. They asked me if I had done that little radar thing. They're trying to find ways to help, so we're definitely going to get that done and do a little radar scope tutorial. Dave is mentioning the pine beetle infestation in British Columbia. Yeah, that's pretty bad there. Ryan says they got a moderate risk fire danger there. And if you want to look for droughts, Drought Monitor. That's a good site you can go to. That's at unl.edu. And that shows where the main drought risks are. This is a little outdated, July 4th here, but looks like the main problems are up in Montana and North Dakota. So, yeah, and even down in western Oklahoma, there are some problems. But I remember 10 years ago, man, it was much different. This whole area was red, and California was red for years. It was very, very bad there. Large wedge tornado confirmed south of Grand Forks. A couple chasers had live feeds on it. And a little discussion there. Sagan's Run, hello from DeWitt County, drying up there. Megan John seeing high VIL values. I can't tell which storm that is. Justin Polly, I'm liking the daily rain. Carl Berghoff looked at his weather station dew point, now 70 degrees, and maybe we'll see some severe weather. SPC outlook is just south of him now. Okay. So yeah, a few high base showers there in Colorado. We do got this storm here near Cheyenne Wells. Got a severe warning on that. 60-mile-an-hour wind gust and quarter-sized hail, and we'll take a quick look at the cross-section. And you can see that this probably looks a lot different from the cells that we see with the intense supercells like Texas, Oklahoma, Minnesota right now. Instead of the higher reflectivities being at the top levels like here and extending down to the ground, we just have the high reflectivities confined to the lowest elevation like that. So that's a good sign that the severe potential is kind of low. I mean, you're definitely going to get some hail and some wind out of this as it collapses, but I don't see any tornado potential on something like this. But we can take a look, one more look at the Grand Forks storm and compare. So let me bring up Grand Forks, North Dakota. And we'll do a cross-section of that storm there. And you can see a much different presentation there. There's the overhang. Let me change the dimensions of this just a little bit. I'll try to go right through the vortex. And there you can see the very intense overhang. High reflectivities aloft, 20, 30,000 feet. And you can imagine if you were flying and did not have airborne radar, you would hit that hail there and be seriously beat up. And that has happened with a few flights. If you look around on the internet, you can find pictures of airliners with hail damage, the nose all beat up and the windows cracked and stuff like that. So sometimes they do have problems, especially when the updrafts are developing and the aircraft are just above that developing updraft, and this kind of develops up into the path of the airplane, and then 2 minutes later they're in the middle of a bunch of hail. Okay, so let's see here. Yeah, a lot of overhang, and tops up to almost, it appears to be up to about 60,000 right there. So these are some big thunderstorms. So this storm has been moving southeast during the weathercast. It started up here when we started, and now it's southeast of Ada. So at this time, I'm not really seeing a definite tornado on the velocity or the spectrum width, but there is the potential, of course, for this to be producing a tornado like below the radar scan or later on as it continues developing. Okay, I think that's about all I got for this weathercast. I appreciate you all watching, and hopefully we will see you tomorrow. Take care and have a great evening.